Hello and welcome to the KCET Masterstroke series for mathematics. We are doing bacha session number 1, which is going to be based on the chapter relation and functions. Yes, this is from PU2. As you know, we are doing the PU2 first. Schedule has already been given to you, where sir, in the community post and in the WhatsApp channel. So I hope you have joined the WhatsApp channel to get all the updates right there. Okay, if you have not joined right now, in this video description you're gonna find the WhatsApp channel's link. Join right away to get all the information and update regarding the sessions, upcoming sessions, the past sessions PDF. Everything will be bacha given in the WhatsApp channel only. Okay, so I hope you have already joined that. So as I said, relation and functions, simple chapter. Sir, why starting from here? Bacha, let's build. No, let's build. Let's start from simple things. Let's quickly learn them, because even though the simple chapter is there, there's still a weightage bacha in this, and the weightage of this chapter will be very, very useful to us. Reason being, simple chapter, questions are coming, then solve the questions and get those marks, right? So very important in that regard. So yes, we're gonna do this chapter today. You'll see, we'll quickly solve this. Some questions I also have taken. So we'll, again, as I said, as you know of the this structure of this program, this Masterstroke series is, we learn all the concepts in one session, we'll revise them quickly, and then we'll solve some questions in the session also. Again, we'll solve a live session bacha in the chapter wise. Like we have, let's say, done 2 chapters, we'll solve live questions, and we'll discuss our doubts in that particular session for both the chapters, or whatever the number of chapters that we have already covered, we'll discuss that in the coming live. Okay, so that is clear. Any other doubt you have about the sessions, let me know in the comment section. Now so I'm gonna start the session now. Okay, so let's see what is coming for you. So first over here is bacha types of relations. You've seen the questions, right? The questions in the relation comes mostly like proving whether this given relation, they'll define the relation R. They'll ask you to prove whether it is equivalence or not, whether it is symmetric or transitive, like that. They'll ask you like that. So we have to check, we have to enable ourselves to answer those questions. We should be able to, know the definitions. We should be able to know the definitions. So from there only we can recollect and solve the result of MCQs. Okay, so we have some definitions over here. Let's quickly go through that. Empty or void relations. Empty or void relation bacha. A relation R on a set A is called empty if there is no element of A related with the element of A. Means bacha, if I'm writing, let's say, relation R A on A, R relation name is relation R, writing on A means bacha from A to A. We can write like that, no? A cross A, that's what we write now. So if I am able to not identify any numbers or element which is related to itself, okay, no element of A is related to any element of A, then bacha we call the set to be null or void set. Means there will be no entries in that particular set. Okay, so empty or void relation, that is there. Universal bacha, whenever we have every single element in the set A related to all the other elements of set A. Think about it. Each of the elements of set A related to every element of A. Let's say I have set A like this. Let's say I have set A like this. Set A is defined like this. Let's say 1, 2, 3. If somehow I define bacha, if I somehow define the one related to 2 to 3, okay, it means bacha, it will become universals relation. 1 related to 1, 1 with 2, 1 with 3. Somehow we can define that. We can do that. No, let's say natural numbers, set of natural numbers. The relation R can be set of natural numbers. Okay, then bacha 1 with 1 is also correct, 1 with 2 is also correct, 1 with 3 is also correct, sir. Yes or no? Yes, bacha. It means whenever we have every element, each and every element of the set related to it, all the other elements of the set will become universal relations. Okay, next sir, we have identity relation. Whenever we have the relation of the elements to itself, only itself, not others. If it is other, then we can't call this as to be identity. Only itself there. Very important. Only itself. Means if I have element, let's say A, we should have the ordered pair as only A comma A. Only A comma A. If we have, let's say, 1, no, then basically the identity will look like this. 1 comma 1, first ordered pair, right? Next bacha will have 2 comma 2. Next we'll have 3 comma 3. I know you all know this, but this is a revision session, right? A fast track, a master stroke for your preparation. So we have to ensure that we have covered everything, right? Even let's say the MCQs ask me on this. They give you options to choose from. Okay, like this they give you this also. 1 comma 1, 2 comma 2, or they give you 1 comma 1, 2 comma 3, 2 comma 2, and 3 comma 3. Ask you to pick a entity relation. You can't pick these two. You can't pick these two. Why, bacha? Because if a relation is defined on A, no, you must have 3 comma 3. And if a relation is defined on A, no, you can't have this in the entity relation. Okay, in the entity relation you can't have this. You should have only the elements related to itself. The elements related to itself. Okay, so I'll read this out loud for you. A relation R on a set A is called an entity relation if every element of set A is related to itself only, denoted by IA. IA equals to A comma A, where A belongs to the set A, bacha. Clear, no? Clear, right? Any doubt you have in this? Let me know in the comment section. Next, sir, reflexive relation, bacha. Now, if I say they are somewhat very similar to your entity relation, then you'll ask, then if similar, then why a different definition, sir? Is there a difference? Yes, there is a difference. There is a difference. What is the difference, bacha? Yes. So basically, in entity, there was it's like a strict let's say guardian or somebody else in your family or friend. Let's say you decided something. Let's say you are going out, okay, with your friends, 3-4 people are going out, plan to eat only Chinese today, okay. Then somebody, might be like person like me will say, no, if you plan, then we'll eat only Chinese. We'll go to a place where only Chinese is there. But somebody might, be able to accept, I can eat Chinese and then I can eat some dessert also, no? I can eat some vada pav also, right? So there can be somebody who is, liking your team goal, okay, but something else is also okay. That's your reflexive relation. Means identity is there. Identity is there. The ordered pair with identity, not a problem, sir. Of course, that is mandatory, of course. We went for the Chinese, we'll eat the Chinese, not a problem there. But other thing we also take, na? Okay. So 1 comma 1, 2 comma 2, 3 comma 3. That though is compulsory. This has to be there. But if I write 1 comma 2, that also is okay. If I write 2 comma 3, that also is okay. Means whenever there is a relation where the element is related to itself and with others also, that's not a problem. Let's say if I say, sir, I have a relation, let's say R, which is identity. Will this be reflexive, sir? Of course. An identity relation will always be reflexive, bacha. But ulta, not true. If I say all reflexive is equal to identity, not always. All reflexive relations can never be equal to or never be identity relation, but all identity relation, bacha, will be always reflexive in nature. I'll repeat again. 1 comma 1, 2 comma 2, 3 comma 3 can come. They have to come. That's a must. But others can also come. Ordered pair other than these also is okay in the reflexive relation. That's why I can take 1 comma 2 and 2 comma 3 as well. Is that clear? Okay. Whereas in identity relation, we didn't have an option like that. Only itself. Only itself. I hope this is clear. Let me know in the comment section if you have a different idea about this particular question. If you have a doubt, if you have an example to ask, let me know in the comment section, right? So symmetric relation next. This bacha, I want to clarify one thing. First, let me just give you a definition of the symmetric relation, then I'll clarify. The only thing that you need to understand over here, if there is a relation R, if there is a relation R, okay, and in that relation R, we have a set like this. This is if condition, bacha. This is a if condition, means this is there. They are saying that this is there. This is there. Then condition is that B comma A has to be there. Has to be there. All of you agree? 1 second. Has to be present. Has to be present, bacha. Okay. Now that is the only thing important over here. For example, if I write, let's say, a relation 1 comma 3 and 3 comma 1 and ask you that is this relation, bacha, is symmetric or not. Let's say defined on set A only 1, 2, 3. What is set A, bacha? 1, 2, 3. 1, 2, 3, there's a set like that, and I'm asking you 1 comma 3 and 3 comma 1. Is this a symmetric relation or not? What is your answer? Your answer should be yes. Sir, there's no 1, 2, 2, 1. There's no 1, 3, or there's no 2, 3, 3, 1, 3, 2. Don't worry about that. Only condition is, sir, if A or B is true. The only condition is, sir, if A or B is true, then B or A has to be true. That's the only condition. We're not looking for all the elements to be, in that format. Just look for ARB and BRA. If ARB is there, then BRA has to be there. Not necessarily that we have to have all the BRA and ARBs from the given set. Is that clear? That's what the doubt of all the students. Sir, 1, 3 is there, 3, 1 is there, but 2, 3 and 3, 2 is not there, sir. So not an anti-relation. You said that if I have 1, 1, 2, 2, but this is not there, not a reflexive relation. That's also very important to know. Let's say I am saying that I am defining like this: 1, 1 is there, 2, 2 is there, but we don't have bacha 3, 3. Is it reflexive, sir? Not reflexive. In reflexive, all elements should be defined with itself. If 3, 3 is not there, bacha, then I can't say reflexive. Not reflexive in that case. Okay, not reflexive. In case of reflexive, all 3 has to be there. 1, 1, 2, 2, 3, 3. But in case of symmetric, 1, 3 is there, 3, 1 you look for. You don't look for 2, 3 and 3, 2. Understand that? You don't look for 2, 3 and 3, 2. Because even 2, 3, basically what I'm trying to say here is, ARB is not mentioned. 2, 3 is what, sir? ARB. If ARB is not there, then why are you looking for BRA? Correct, na? So if 2, 3 is not there, not a problem. 2, 3, 3, 2 not there, it's okay. Just look for this condition. If ARB is there, then BRA has to be there. Agreed? Okay, sir. So symmetric is that only. Okay, check this out. If ARB is there, then BRA has to be also in the relation where A and B belongs to the set A. Of course, where the relation is defined, right? On the set A. Chaliye. Transitive relation, bacha. This is again if and but condition. Check this out. So if there are 2 ifs here, 1 second. Okay, so a relation R will be called reflexive, bacha. Sorry, transitive. When you have these conditions, what is that? If condition will be, if you have ARB, you should also have BRC. You should also have BRC. These are 2 both if conditions. Then, bacha, ARC should also be there. Thinking about it, if 1, let's say I have a relation like saying that 1, 2 is there. 1, 2 is a ordered pair in the relation. We also have 2, 3. We have 1, 2, we have 2, 3. Then, bacha, what should happen? 1, 3 should also be there. 1, 3 should also be there. 1 second. 1, 3 should also be there, sir. Chaliye. That's what it is. Okay, ARB, BRC, then ARC should also be there. Okay, chaliye. This is going to be the definition of transitive relation. This is simple. Of course it is. Let me know in the if you have a difference of opinion. If you want something else, you let me know in the comment section. Now, sir, next, equivalence relation. Is it difficult? No. If I have a relation which is transitive, symmetric and reflexive, all 3. If it is, what is this, bacha? A to A means the reflexive. Okay, and we have ARB. Check this out. ARB, BRA. It means, bacha, symmetric. Okay, what next, sir? A comma B R belongs to R, B comma C belongs to R, then A comma C also belongs to R. It's a what, sir? Transitive. Excuse me. Transitive. Then what we call, sir? We call this relation R to be equivalent relation. We call it to be equivalent or equivalence relation. I hope this is clear. Yes, that's all the concept which is there for your relation, bacha. That's how simple it is. Yes, sir. Okay, let's see some questions now. I've taken few questions over here. Question number 1. For any 2 real numbers, A and B, we define ARB if and only if sin square A. Basically, bacha, they have given here the relation. What is the relation, bacha? Sin square A plus cos square B equals to 1. Sin square A plus cos square B equals to 1. We have to prove whether it is, which of the option is correct. Whether it is reflexive, not symmetric, symmetric, not transitive, transitive but not reflexive, or an equivalence relation. Let's check this out. We'll check for first, bacha, what? Reflexive. Let's check for reflexive, sir. So part 1 is checking for reflexive. Okay. So how will I write this? It'll be ARA, right? For reflexive, we have the relation ARA defined. Okay. So we write like this: sin square A plus B will become cos square A only. And this is 1, right? That's the entity, first entity that we learned, grade 10. Yes, sir. It means reflexive is true. This is always true, right? This has to be the case. They're saying that a relation will be defined only if this statement is true, sir. That's we got here. It means correct, no? For ARA, this is true. Let's look for symmetric now. Symmetric will look for bacha. What is this going to be? ARB is there, then BRA also has to be there. Let's look, write for ARB first. Write like this: sin square A plus cos square B equals to 1, right? Then we have to prove that if this is true, means sin square B plus cos square A also has to be 1, sir. How can we prove that? Check it out. So what we can do is use identity over here again. How, sir? I'll show you, don't worry. I can write over here sin square A as 1 minus cos square A, and I can write, sir, cos square B as 1 minus sin square B. Now put it back in this form. Okay, what I get? 1 minus cos square A plus 1 minus sin square B equals to 1. What I'm getting, bacha? 1 plus 1 is 2. 2 take minus sign common. I get cos square A plus sin square B equals to 1, right? Do one thing, bring this bracket on this side and this 1 on this side. What I get? 2 minus 1 equals to, bacha, this negative will become positive, so I'll get plus cos square A sin square B. How much is this? This is going to be 1 only, no sir? This is going to be 1 only, sir. So basically this is ARB, and what we're getting here? BRA also is true, sir. BR is also true, sir. Correct, na? Sin square B plus cos square A is also coming equal to 1. So relation is defined properly. It means symmetric also is true. Symmetric is also true. The relation given is symmetric as well. Now let's look for bacha transitive. What we have now? Chaliye. So we'll write first ARB. What is ARB, sir? Sin square A plus cos square B equals to 1. Now write, bacha, BRC. So it will become, bacha, sin square B plus cos square C equals to 1. Add both the equations. It will become, bacha, sin square A plus cos square B plus sin square B. Write it together. Cos square B plus sin square B. Write it together. Okay. Plus this part, cos square C equals to 1 plus 1. So 2. Okay. Sin square A remains as it is. And this will become, bacha, 1. Sin cos square B plus sin square B is 1, so the identity, and will be as it is, cos square C equals to 2. Bring this 1 on this side. What I get? Sin square A plus cos square C equals to 2 minus 1. So simply 1. This is my answer. Please check. Sin square A plus cos square C. What I'm getting from here? A R C. When it is ARB, sir, sin square A plus cos square B. BRC, sir, sin square B plus cos square C. Sin square A plus cos square C, sir, ARC. It means when this is true, this is if condition, sir, then this is also coming true. Hence transitive also is correct. Transitive also is correct, sir. What we get? Option is option number D. Option number D is correct. Had fun? Good question? Yes, please check. Question number 1 is done. Let's move on to question number 2. Okay, for the set A, 1, 2, 3, define a relation R on the set A as follows. Okay, 1, 1, 2, 2, 3, 3, 1, 3. How many? So let's write the relation over here. Okay, how many ordered pairs? Let me write the relation first. R equals to 1, 1, 2, 2, 3, 3. So reflexive is there, sir. Okay, 1, 3. Okay. Then this is closed. How many ordered pairs to be added to the relation R to make it the smallest equivalent relation? Small is very important, sir. This is a very important word. Means we're looking for the first, basically the first time when this relation becomes equivalence. So how can we do that? Let's look for what is the condition that is not making it equivalent. Means if right now they are saying that it's not equivalent. No, they are saying that not equivalent right now. Not an equivalent relation right now. That's what they're saying. Okay, so let's look for the reason for the unequivalence relation. What is the reason that is causing it to be non-equivalent relation? Okay, and we're gonna add that to make it equivalent. That simple as that. So is it reflexive, sir? Is it reflexive, sir? Yes, bacha. Reflexive, correct. Check this out. 1, 1 is there, 2, 2 is there, 3, 3 is there. So correct only, because they have given here the set is defined like this: 1, 2, 3. We learned it. After this, anything else is there, not a problem. This has to be there. Okay, so reflexive, true. Symmetric, bacha. Symmetric. Sir, 1, 1. We don't check these numbers for symmetricity. Do we check for symmetric? Because 1 1 is there means we won't check the symmetric. It's like that, it's present there only. What about this 1 3, sir? It means 3 1 is missing. So we write here 3 1 is missing. Okay, means if I add 3 1, it'll become symmetric. Agree with me? If I add 3 1, it'll become symmetric. So that's true. Let's look for transitive now. So this we won't check. This moment we won't check. No, they will. We know, you know, chances of what do you call non-transitivity from this options A comma A. Okay. Now 1 comma 3 is there. So what we need, bacha? We need 3 comma. If I have 1 comma 3, let's say I have 1 comma 3 and 3 comma 1. Right. That's all. We are adding this part. We are adding this. No. Yeah, adding it over here. So 1 comma 3 and 3 comma 1. 1 comma 3 and 3 comma 1 we have. Okay. Now, so check this out. A R B, B R, again A only. What do you get from here? A R A. That's there, sir. 1 comma 1 is there, sir. Okay. Anything else will make? No, sir. We won't check anything else. No. If I check this like this, 3 1, we can't check only, sir. Only one thing is there that is missing. If I put 1 3 and 3 1, that only we can be checked. Other is not creating any, you know, cause of non-transitivity. So I get, if I add 3 comma 1, it will become transitive also. If I add 3 comma 1, sir, once this is done, it will become transitive also. It means only one ordered pair is required to make this relation smallest equivalent relation. Right? After adding this, is it equivalent? Yes, sir. It's equivalent only because it's transitive also. Okay. Chaliye. So answer would be option number A. 1 is the answer. Just we need to add this 3 comma 1. That is what is missing. That's your answer. Got it? Let me know if you have a doubt regarding this in the comment section. Now, sir, we are going to move to types of functions. Okay. So we have, sir, surjections, bijections. We'll see all of that. So what is it? The first thing, 1 1 or injective function. 1 1 or injective function. There are two different names for it. Either you call 1 1 function or you call injective function. What is the meaning of this? But whenever the elements of your domain, okay, means basically if I have defined like this, A to B, whenever the elements of domain, okay, are distinctly related, means uniquely related to the elements of codomain, or we also call that to be range later. Okay, let's call it codomain right now. B is codomain and A is domain, right? So whenever the elements of domain has unique relations in the unique mappings in the what do you call in the codomain, okay, then we call that relation to be a function. So function f is defined, is called 1 1 if the distinct element of A, means different elements of A like this. Let's call it to be a 1 2 3, and bacha over here we call this set B, let's say A B C. Then I get bacha 1 with A, 2 with B, and 3 with C. That's the mapping. Okay, that's the functions mapping. When I have this kind of case, then I'll say bacha what? Then I'll say, sir, this will be 1 1 function. Unique relation, right? Distinct element with distinct elements or images in B. That's why for every x1 comma x2, okay, which is not equal to each other, what will happen? The function is also different. For 1 I get A, for 2 I get B. 1 is not equal to 2, also A is not equal to B. What is A, B called, bacha? A, B, C are called images of the elements of set A. I'll repeat again. A, B, C are called images of the elements of set A. With what is this 1, 2, 3 called, sir? Pre-images of the elements of set B. I'll again repeat. A, B, C is called as images of the element of set A, whereas 1, 2, 3 is called as pre-images of the elements of set B. Correct, na? Chaliye. So that is what it is. Whenever I say, bacha, that fx1 equals to fx2, then what has to happen? The number has to be equal. That's what is uniqueness means. This is the method of what you call, this is the method of algebraic approach to identify a function to be 1 1. This is the second approach, sir. There is a second approach. Second approach is also there. What is that second approach, bacha? We draw a graph of the given function, okay, and after this part what you do is draw a line parallel to x-axis. Draw a line parallel to x-axis. If you get unique intersection, it means 1 1. It should have unique intersection, sir. intersection. So what I mean by that, like this, okay, like this. Draw a line parallel to x-axis, bacha. How many intersections are there? Only one, no? So unit intersection. Let's draw a graph like this. I get, bacha, how many intersection? 2, sir. Over here and over here. It means more than one, not unique anymore. It will become not 1 1. Not 1 1, okay? And not 1 1 is called as many one function. Not 1 1 is called as many one function. This is 1 1 function, this is many one function, okay? So just opposite, whenever you won't have a, what do you call, you won't have a unique relations, okay? There exists at least two means more than 2 also is okay. Distinct element in A whose images are same in B. What is the meaning of this? Check this out. So if I write this 1 2 3 A B C, again this is set A and set B. So at least 2 elements in A which has same images in B. So like this, bacha, 1 and 2 both has image A only. So the image of the element 1 and 2 is both coming as the element A of set B, okay? Then it's called as many one function. Many to one, sir. Is it clear? Is it clear? The graph will have more than one intersections, okay? The graphical approach will have more than one intersection. What about algebraic approach, bacha? This part. Whenever you take x1 not equal to x2 and you get fx1 and fx2 equal. Check this out. If I take x1, bacha, as 1, x2 as bacha 2, okay? Is x1 equal to x2, sir? No, sir. 1 is not equal to 2. But what is, bacha, f of 1? Tell me. It's coming as a, sir. And what is, bacha, f of 2? Also coming as a, na, sir. Think about it. F of 1 mapping to a, f of 2 mapping to a again, f of 2 also mapping to a again. It means, bacha, what I get f1 or f2 both equal. What I get, sir? f1 equal to f of 2. Okay, so I'm trying to say that even though the x1 is not equal to x2, okay, the function value at that point is equal. Whenever we have that many one, the function value at the point x1 and x2 are equal to each other, even though x1 is not equal to x2. This is the way to identify using algebraic approach. We have done so many questions like that. Yes, please go ahead, solve some questions on that. We'll again discuss it in the live session. Okay, chaliye, this is clear. Okay, moving on to second, first category is done, 1 1 many one. Second category is, sir, onto and into. Onto and into. What is onto, sir? Also called as surjective function. Also called as surjective function. How do you define it? Whenever, bacha, in simplest way possible, I tell you, whenever the range and codomain become equal to each other. Sir, what is range, sir? You said codomain so far. Codomain, what, bacha? What is codomain, sir? This part. This B is called as simply codomain. This is called as codomain. Then what is range, sir? What is range, sir? How do you define range, sir? Range is, bacha, nothing but set of all images of elements from where, bacha? From domain. From domain. So for all the elements that are there in domain, bacha, you take the images of that and bring it in a set. That's called range. That's called a range, sir. Basically, I can show you. So let's say this is codomain B, okay? And this is domain A, okay? I write here 1, 2, 3. I write here, bacha, A, B, C, D. A, B, C, D. Let's say 1 related to A, 2 related to B, and 3 related to D, sir. 3 related to D, sir. Okay. So can you see what is the range, bacha, in this case? What is the codomain, sir? Codomain, if I have to write. Codomain, if I have to write. So codomain is, sir, A, B, C, D. What is codomain, sir? A, B, C, D. What is range, sir? Bacha, the range will be what, sir? Only A, B, D. Only A, B, and D. So can you call codomain and range are equal? No, sir. What are you going to say? Codomain is not equal to the range in this given example. Not equal to the range in the given example. Then we call the function to be into, sir. Then the function to be into function. So whenever you have something extra left out in the codomain, for the after you do the mapping, right? Whenever you have something left out in the codomain, then we call the function to be into. Whenever it is not the case, whenever you have no extra part in codomain, basically whenever you have range becomes equal to codomain, whenever you have range equal to codomain, sir, then you call the function to be onto. Then you call the function to be onto. Getting it? Please check. A function f a to b is called onto or surjective function, different name for it, if each element of b is the image, means each element of the b is the image of some element of a under f. That is, for every element y belongs to b, there exists an element in x such that fx equals to y. In other words, f is onto if range equals to b. What is b, bacha? Codomain of f. Simple, right? Simple words. Range becomes equal to codomain. What is range, bacha? Range is the set of all the images of the element of domain. All the images. So domain, what is the element? 1, 2, 3. Set of all the images of the elements. So 1 ka image is A, 2 ka image is B, 3 ka image is D. Set of the elements of the images. So ABD. That's why the range is ABD. If it is equal, then onto. Not equal, then into. Okay, please check. A function f, when bacha no pre-images, means if you have something like this C which doesn't have pre-image. If I ask you what is the pre-image of C, what is the answer? Tell me. Pre-image of A, sir, 1, pre-image of B, sir, 2, pre-image of D, sir, is 3. What is the pre-image of C, bacha? Nothing. Nothing is there. It means when you have an element like that which has no pre-image in A, if there exists an element in B which has no pre-image, then you call bacha the function to be into function. Function to be into function. Clear? Very simple? Of course, sir. Very, very simple. Now, note to identify that let a function is defined like this, bacha, a to b, then consider a y from, take any element from the codomain. Take any element, bacha, from the codomain, b any arbitrary element, okay? Now put y equal to fx, okay? And solve it to obtain x in terms of y. Basically, what are they asking you to? Make x subject now. Usually what happens? What is the subject, bacha? Subject is y, sir. What is the subject, bacha? Subject is going to be y. What are they asking you to do? What I'm asking you to do is make subject x, sir. Make the subject x, bacha. Make x subject of the equation, okay? You can do that, no? Make x subject, okay? Now for every y belongs to b, corresponding value of x does not belong to a, then f is into. Not onto means into, sir. What I'm trying to say is, let's say I have a function defined f like this, natural number to natural number, okay? Natural number to natural number, okay? And when you are, let's say this is your codomain, no? This part is codomain, sir. So if you take any element from codomain and put it in the equation and solve for x, you're getting x as a fraction. Let's say you get x as a fraction. Can a fraction be, bacha, ever? Can a fractional number, a decimal number, can never be natural number? Of course not, sir. It means for some values in codomain, I'm getting a function, getting the x value as a fraction at a decimal point. It means, bacha, the function will not be onto. The function will not be onto, sir. Because when you took the y to be natural number, you're getting x as a decimal, sir. Decimal means, what, bacha? Decimal means x is not equal to. 1 second. Means I'm getting that particular value of x not equal to natural number, sir. Not equal to natural number, sir. Which cannot be true, sir. How come? Because they're saying that x has to be natural only, no? What is the domain, sir? Natural only. So whenever you have this contradiction, what do you say? You say the function is not onto or simply into. If it is not the case, you will take simply the function to be onto. I'll repeat myself, very important. Algebraic method. The method to solve this, bacha, is going to be what, sir? Going to be what, sir? Write the function x given in terms of y. Basically, first step is, sir, make x subject. What is the step 1? Step 1 is make x as subject, okay? Now, take some value of y. Take y that is from the set B. Any value of y you can take, okay? In set B, and look for, if you can, bacha, take that and x is coming which is not a part of set A. What is set as a natural number? Then we'll call the function to be into, sir. If x is coming not equal to or not belong from set A, bacha, it will become into. If it is coming means it will be onto. Okay, try to check, try to prove it is not, because it will be difficult to prove, for all the points onto, because you can get onto all the time. You have to look for the point where it is not onto, it will become into. Okay, I've done questions like that, don't worry. Okay, please go ahead, revise my previous sessions, and again I'm going to do some more questions in your coming live sessions as well. This is clear? Okay, now sir, the last one is 1 and onto function, also called as bijection or bijective function, right? What do you do in this? A function f a to b is called 1 and onto if it is both, of course, as the name suggests, 1 and onto. Basically what it means, distinct elements of a have distinct images in b. 1 definition. What is this part, sir? This is definition of 1 sir, na? What about this bacha? Each element of b is image of some element of a, means none of the elements in b is left behind. None of the element in b is left behind, okay? So onto bacha, onto sir. So we call this type of function to be bijection, okay? Don't worry, we'll solve the question like that right now. Before, I have some things to explain you, some points. Sometimes they ask questions on this as well. That's why to leave it. Number of functions, number of injections, number of bijections. So whenever you have a function defined like this, a to b, a is the domain, b is the codomain. Number of elements of a is m sir, and number of elements in b is n sir. Then the number of function will be given by n to power m. N to power m. Okay, n to power m. Also, if you are looking for bacha only injections, which is on one function, also called as number of injections, not the one that you get in medical clinic. Okay, injections means number of injective functions bacha. What does means? Number of injective function or number of one function, not the medical one. Okay, so number of injective function will become what, sir? npm. Just remember this formula, npm. What it means? N factorial upon n minus m factorial. npm, sir. N factorial upon n minus m factorial. Okay, please check. Only if n is greater than m. What is n and m bacha? Number of elements of b and number of elements of a, sir. Okay, now looking for bacha number of, this is called as number of surjections. Number of surjections. Okay, means number of onto function. Okay, number of surjections means number of onto function. If defined like this, when n is less than equal to m, we get bacha summation from 1 to n minus 1 power n minus r, n times of cr, ncr. What is that bacha? Sorry, is ncr, sir. ncr r power m. Okay, please check. Okay, chaliye, the last one, sir. This is actually where the questions are asked most of the time. This and the first, this part. The number of bijections in n factorial. How much is that bacha? So if you have given here that m equals to n, means whenever the number of elements of a and b are equal, number of elements in a and b means number of elements in domain and codomain are equal bacha, then bacha we're looking for bijections. Okay, number of bijections means number of one function. So number of one onto function, we call simply that to be n factorial, na sir. N factorial, sir. Okay, chaliye, now we'll move on to questions now. So I've taken 2 questions already. This is my 3rd question. We're going to solve 2-3 more and end the session. That is okay. That is okay for all of you. Yes. The function f is defined like this: r to r, relation number, real number to real number. Okay. Fx is given by 6 power x plus 6 power mod of x. Let's look for the function's nature. 1 onto, many 1 or into, like that. We'll check that. Don't worry. So let's do one thing. Define the function like this, bacha. So we'll write it over here. I can write the function to be. For x greater than equal to 0, what happens to the function, sir? For x positive, what happens to the function, bacha? The function will become f of x becomes equal to 6 power x as it is, and will become plus 6 power x. How much is that, bacha? 6 power, 2 times of 6 power x. Okay, 2 times of 6 power x. That is clear. Okay, can you find derivative quickly over here only? Why derivative, bacha? We're looking to draw the function's graph, that's why. Okay, so 2 is a constant, write it like this. Differentiate this exponential function, it will become 6 power x ln 6. So constant, we can keep it with the same 2 ln 6 with 6 power x. That's the function. Okay, f dash of x. We know this 2 and ln 6 are positive numbers. ln 6 is a positive number, 2 is a positive number. Okay, and 6 power x, bacha, is the exponential function, always positive number. It means f dash of x is greater than 0. Agreed or not? Think about it. Positive, this is also positive. Means bacha, f dash of x is always greater than 0. It means, sir, fx is increasing where, bacha? When x is greater than equal to 0. You know this now. Whenever the derivative is positive, bacha, what happens to the function? Is it increasing kind in that particular domain? What is the domain, sir? X greater than equal to 0. Let's look for the other one. What is that other category? X is less than equal to less than 0 sir. Acha, why we are looking at 0 bacha? That's the critical point, that's why. That's the critical point sir. Check this out, x mod is there, no? That's why. When I take less than 0 bacha, what happens to this? Less than 0 sir, if I take, what will happen to this part? Please check. It'll become 6 power x only plus 6 power minus x. Correct, na? Mod x will be open with minus sign, that's why minus x. Okay, this is my fx sir. Differentiate it now. It'll become ln 6. What else will be bacha? 6 power x as it is plus, again same thing will come, ln 6 power minus x into minus 1 will come. For minus x, chain rule I'm doing. Applying chain rules, first differentiate this part will become as it is, and you have to apply the, for minus x also becomes minus 1, chain rule. Okay, what I'm getting for this is my fx. Okay, check this out. I can take ln 6 common. I'm getting here 6 power x minus, this my sign will come here, 6 power minus x. Okay, this is my f dash of x, right? This is my f dash of x, sorry, f dash, or derivative is there. Okay, now let's look for the nature now. It's a positive number, this is positive. Okay, that's positive. What about this bacha? What about this sir? It's negative actually. Think about it. If x is less than 0, what will happen to 6 power x? Okay, it'll become smaller, no? It'll be smaller actually. It'll be smaller than 6 power minus x, no? Correct, right? It'll be smaller than 6 power minus x. What will happen then? It'll become negative, sir. Think about it. For x less than 0, okay, it'll become bacha smaller, right? So 6 power x will be smaller than 6 power minus x. Correct, right? Because it will be actually a negative number, this will be positive number. Think about it. If I take bacha x as minus 2, what will happen to this? 6 power minus 2, this will become bacha 6 power 2. It will become 6 power 2. It will become 6 power minus 2. How much is that? 1 by 36. And this is 36. Isn't this less? Think about it. Yes? Okay, I'll erase this part. 1 second. Let me just take it out. Basically, what is the understanding? X less than 0 bacha, 6 power x is less than 6 power minus x. Okay, it means sir negative plus into minus, what is that going to be? Sir, derivative will be less than 0. Okay, it means sir fx is decreasing function. Decreasing, okay, when bacha? When x is less than 0. Okay, can I draw the graph for this part? Check it out. Can you draw the graph for this part? Okay, it will become, think about it. Will it be lower than 0? Will it be lower than 0, sir? Never, no? Because they are both exponential function. No, this can never become less than 0, can it? Exponential function, it can never be less than 0, okay? So the function will go like this somehow. Okay, when it be, sir, when you take x as 0, it will become 1 plus 1, no? So 2. Okay, like this. And when it is x less than 0, it will become bacha, this is increasing, this will be decreasing, sir. Correct, no? Right? Correct. Okay, so what I'm getting here, check this out. Check this out, sir. Like this. I'm getting a bacha 2 point of intersections, no? I'm getting here 2 point of intersection, right? Agreed. Okay, so what I'm getting over here, function is not 1 1, not 1 1. First point is not 1 1. Because we have 2 point of intersection. Correct, right? What about onto bacha? Not possible. No, please check this out. What is the range here, sir? What's the range, bacha? Only positive. Only positive real numbers. Not even 0, not even negative numbers. How come, sir? Is there a graph in this part? No. Can it be there? Think about it. Can it be there? No, sir. How come, bacha? The function is exponential function. Exponential function never comes to the line, below x-axis. Never it comes. Okay, what is the graph of exponential function, bacha? Like this. Remember, this is the graph. Either this or this. Check this. Not below 0, of course. Not below 0, of course. It will be always above the x-axis. It will be always above the x-axis like this. Right? So never below 0. It means, bacha, only r plus is there. It means range is not equal to codomain. What is codomain, sir? R. Codomain is r, sir. It means range is not equal to codomain. What I get, bacha? Not onto. What is the answer? Not onto as well. So not 1 1, second part, and not onto. Not 1 1. Okay. So not 1 1 means many 1, right? Not 1 1 means many 1. Not 1 1 means many 1. And not onto means into. So many 1 into is option, yes, option number D. Option number D is correct. Many 1 into. Many 1 into. Please check. A very good question. Okay. Have a look. We had to do the derivative to find the nature of the graph. That's why. Please have a look. Question number 3 is done. Question number 4 now. Set A has 3 elements and set B has 4 elements. The number of injections right? 3 and 4 injections, okay? It'll become bacha this, no? 4p3, I think. So 4 factorial upon 4 minus 3 factorial. So 4 into 3 into 2 by 1 factorial. How much is that, bacha? 24, right? 12 into 2 is 24. Answer is option number C. Please cross check your answer for question number 4. It should come as 24. Should come as 24. Please have a look. Question number 4. This is clear? Okay. Now this is fx equals to x plus root of x square. Okay, it's a function from R to R, then fx is injective, surjective, bijective. Okay. Alright, this is fun. Check this out. Fx equals to x plus root of x square. No, what it means, bacha? It means I'll get here, sir, mod x, no? How come, sir? I'll get plus and minus both, right? So mod x I can write. I take square root of any number, I'll get both plus and minus, so that's why mod I'm writing here. So if I take bacha x as positive, we'll get bacha fx will become x plus x. How much is that? 2x. If I take, sir, x as negative, okay, what will happen? Fx will become, how much is that? X minus x, no? How much is that? 0. Alright, 0, sir. Can we draw the graph? Can we draw the graph? Okay. Draw the graph, this part. This will be easier with the graphical approach. Check it out. First part is, sir, this, no? The curve is this. Okay, this is the curve. Okay. After 0, this is the curve. Before 0, sir, it is always 0. This is the curve. Okay. So, of course, not 1, 1. Not 1, 1. How come, sir? Because, bacha, if I take this line, no? If I take this line, I have infinite number of intersections. If I take this line, y equal to 0. If I take this line, y equal to 0. This is a line parallel to x-axis, which is basically x-axis, no? How much is that? Simply x-axis, sir. What happens, bacha? I have infinite number of intersections. Infinite number of intersections. Which means, bacha, not 1, 1. Which means not 1, 1. Next, bacha, on to. Sir, it is defined on real to real, no? Defined on real to real. Okay. So what is the range over here? Check this out. The range is coming as 0 closed to infinity open. 0 closed to infinity open, no? How much is that called? Basically, it's called as R plus 0. Basically, 0 to infinity, no? I have to write here, sir, R plus and 0. Both has to be true, okay? Or basically, R minus R negative. From the real number, remove the negative real numbers. Okay, but what is the codomain, sir? Codomain is all real number. Codomain is all real number. What we can say? Range is not equal to codomain. Means what, bacha? Not onto. Not onto. So not 1, 1, not onto. Any option like this? Injective not possible because this is 1, 1. Not onto. Bijective not possible. So answer is, bacha, option number D. Now these. Answer is option number D, sir. The answer is coming as not 1, 1, not onto. What is this? Check here. Not onto and not 1, 1. Not on because of infinite number of intersection. Not onto because of range not equal to codomain. Codomain, okay. Please check. Codomain, sir. All right. Not visible, right? 1 second. I can do it better. So, bacha, this completes our session today. I hope you had fun. I hope you learned something today. I hope you enjoyed the session. Let me know your feedback. How can I improve it? Anything you want from my side, let me know in the comment section. Now this is the time to be more interactive. Ask your doubts, ask your concerns. I'm going to help you in any possible way that I can. Okay, so this is it. Have a look one last time, and I'm going to conclude the session today right now. So I'm waiting for your feedback from all of you. Okay, I want more engagements in your live sessions. Okay, that's my request from my side. I want you to do better. How can you do that? By being with me, by working more and more with me. Okay, so with this positive note, I'm ending the session today. I'll see you in the next session. Till then, you have to take care of yourself. Bye bye.